Hi, today we're going to talk about multi-class classification accuracy. How do you measure it? So what is a multi-class classification? Basically, when there's one answer to choose from a set of options, our model is given some input and it has to choose between a set of possible outputs, and only one of these outputs is a correct value. Let's say that our model is trying to predict the genre of music given some music as input. Let's say it's going to try to predict between whether the genre of music is rock, jazz, or classical. Let's say we give it a song, the Moonlight Sonata would have to be classical. So how do you measure the accuracy of a model that's doing multi-class classification? Three main metrics to look at: precision, recall, and the F1 score. The F1 score is just the average value of the precision and the recall. But essentially, you'll be given a matrix like we have over here called the confusion matrix. And don't let that confuse you. It's just a matrix which shows you what our model predicted correctly from a set of examples, where the row values indicate our predictions for our model and the column values indicate the actual answers for the input that we're giving the model. We can see here that our model has a set of 35 examples, and 10 of those it predicted to be rock, 15 of those it predicted to be jazz, 10 of those are predicted to be classical. We can look at the columns to see what the actual values of these 35 examples were, and we see that 11 were actually rock, 10 were actually jazz, and 14 were actually classical. Now for the columns in the diagonal, which are 5, 6, and 7, these are the actual values that our model predicted correctly. For the rest of the values that are not in the diagonal, that means our model made a mistake in classifying the example. In row 1 and column 2, our model incorrectly predicted two values as being rock when they were actually jazz. I hope that makes sense. You can see here also, it incorrectly thought that 3 examples were rock when they were actually classical. Here we have the same confusion matrix, and now we have to calculate the precision. Since there's 3 values for our classes that could be the answer, we have to calculate 3 precision values. So we'll have a precision value for rock, and a precision value for jazz, and a precision value for classical. Now the formula for precision is equal to true positives plus false positives. Now here we know the true positives are just the values in the diagonal, since these are the values that our model actually got correct. So we can see that our model got 5 rock values correct. So it predicted 5 examples as being rock and they were actually rock. And it got 6 values for jazz correct and 7 values as classical being correct. We already know the true positives for each one of these. Pre-rock is 5, jazz is 6, and classical is 7. Now we have to calculate the true positives and false positive values. This is just another way of saying how many predictions did your model make for a given class. Here we can see that our model made 10 predictions for rock class and 15 predictions for the jazz class and 10 predictions for the classical class. So the true positives and false positives for rock would be 10, and the true positives plus the false positives for jazz would be 15. For classical, it would be 10. Now we can find this to be 0.5, this to be 0.4, this is 0.7, and then we average them. Just take 3 values and divide by 3. 0.533. Now let's take a look at the recall. So the recall is similar to the precision, except this time instead of looking at the values along the rows, we're going to look at the values along the columns. In this case, we're going to see the values that our model predicted correctly and comparing them against the amount of values that are actually belonging to that class. Again, we're going to have a recall for rock, a recall for jazz, and a recall for classical. The formula for recall is similar to precision, except it's considered to be the false negatives plus the true positives in the denominator. What are the false negatives? They're the values in the column that are not the diagonal. They basically show you how many values your model missed for the class that actually belong for that class relative to how many correct values it got to that class. So here we're going to see the true positive values are the same as the ones that we got for the precision. So it'll be 5, 6, and 7. And now we can see the values in the columns that actually belong to the given class. So there's 11 values that belong to rock, and 10 values that belong to jazz, and 14 values that belong to classical. These values in the bottom are actually false negatives plus the true positives for the class that's labeled above here. So we can just put 11, 10, and 14. Again, just like precision, we have to get the average value for recall. 5, 0.6 plus 0.5 divided by 3. Now this translates to a percentage, much like the precision translates to a percentage. Now to calculate the F1 score, just the harmonic mean, we actually have to calculate the F1 score for rock, the F1 score for jazz, and the F1 score for classical, and then average them. F rock is equal to 1 for 1 over the precision value for rock plus 1 over the recall value for rock. Now this formula simplifies down to 2 times the precision times the recall over the precision plus the recall. To get F average, we take the F1 score for rock plus the F1 score for jazz plus the F1 score for classical. Divide that by 3 and we get approximately 0.5132. The way I showed you how to calculate these values is called the macro average approach. There are other ways to calculate these values, such as the micro averaged approach and the weighted approach. Another thing to take into consideration is that when we got the average values of the metrics, we are comparing the average scores. If you want to get a better understanding as to how well the model does for specific classes, I take a look at the precision values and recall values for that specific class. The averaged values of the metrics are meant to be a comparison between different models. So you can imagine us having many models which have different confusion matrices with different accuracies for each of their metrics, and we can appropriately quantify or measure how well each model is by using these average values. That's it for the video, guys. Thanks a lot for listening, and look forward to seeing you soon.